So let's get started. We'll give probably a minute or two to Vedansi, but we should be good to get started. So we are going to start with the topic on inverse functions. So what is your understanding of inverse functions, Arush? Anything that you can think of?
Inverse functions are when the x and y are flipped in an equation where y is equal to mx. Inverse function that would be x is equal to my, and you can simplify from there.
In terms of trigonometry, if you relate, how would you talk about it?
Trigonometry, I don't think that they said how to spell trigonometry.
Oh, okay. All right. So let's see. There are two things that we come across. Okay. Let's say if I have x to the power 2, we know it's x into x. If I have x to the power minus 2, this is what we have learned as part of exponents, that it becomes 1 over x to the power 2. Correct? So this power that you see is an inverse power, a negative power, a negative exponent. So if you have x to the power minus 1, this becomes nothing but 1 over x. Yeah?
Yeah.
But in case of trigonometry, let's say if I'm talking about sine theta, it has some value. If I say sine inverse of theta, it doesn't mean 1 over sine theta. Okay? It means something different in trigonometry world. Okay? So it's also called arc sine or inverse of sine theta. And we'll talk about that. Let me just see. Okay, so we'll decode that, but before we go further into it, let's see what all we remember and what is still unknown or unclear. So if I'm talking about, let's say, okay, here comes Vedansi. Hey Vedansi, good morning.
Good morning. Sorry, there was tech issues on our side.
No worries, Vita. It's okay. So this is your first class. It'll not be. Let's start with introduction first. So you can see the full board, okay, and hear me, okay?
Yes.
Okay, and you are based in Chicago, correct?
Yep.
Okay, so we are in the same time zone. Now there are a couple of things that you would want to be aware of. That this class, this is primarily for pre-calculus, which is on the top of what we know as the core topics till 10th, 11th grade, right? So this topic assumes that we are very clear with all the other basic concepts, but there could be something that would not be clear. You can feel free to ask me. I'll try clarifying it. I would not want to just rush and complete something. We would rather focus on building the concepts, okay? So, and the other thing is, when I'm teaching something, you don't have to worry about taking notes, because everything that I do is getting recorded. So I'm getting recorded and the board is getting recorded. So you can watch the video of the class afterwards and revise what we learned, so that you can save some energy and effort from taking notes. Alright? So let's focus on concepts, and anything that we talk about, if something is not clear, please feel free to ask me. I'm supposedly not a very scary teacher, so feel comfortable with it, okay? Alright? And I treat all my students as my kids, so if I show that extra care, don't worry about it, okay? I address everybody as my son, my child, my beta, okay? So don't worry about it. Yeah? So feel comfortable and ask questions. So, we have just started the pre-calculus topics. The first unit of pre-calculus we have not covered. And in this class, let's say I'm going in my flow of topics one after another. But in between, if you have something being covered in the school and that you wanted some clarity, just let me know a couple of days in advance, so that way before the class I can cover that also for you. Alright?
Okay.
Alright, so let's get started. So let me make sure that I'm calling your name correctly. Vedansi, right? That's how I pronounce it?
Yes.
Okay.
Yes.
So Arush, just bear with me. I'm just checking how comfortable is Vedansi with respect to all some of the basic constructs of what we are going to cover in the class today. And we are going to cover inverse functions. So let me go in the inverse order itself. So what is your understanding of, I have checked with Arush already. I wanted to check with you, Vedansi, what is your understanding of inverse functions in trigonometry?
In trigonometry, we haven't really learned about inverse functions in trigonometry,
Oh.
but I do know that inverse is like when you flip the x and y values to so the x would become the y values when you inverse it. Also, we also learned that inverse can only happen in an inverse function can only happen when the parent function is a one-to-one function.
Okay. All right. Let me take one more step. So there's some correction that we would need to bring in to ensure our understanding is correct. But how comfortable are you with unit circle?
Unit circle, I would rank it an 8 out of 10. I understand the concept, and I'm pretty confident in it.
Oh, so that's why I was wanting to hear that from you, so that I can calibrate my pace accordingly. Okay.
Okay.
And you can understand me, okay? I mean, I'm not speaking very fast or not. My accent is not bothering you.
No, it's perfect.
Oh, okay, wonderful. So let's start. So when we talk about inverse functions, before I go to inverse functions, let's do a quick recap of what we know with respect to unit circle. Okay. So we talk about unit circle trigonometry as the unit or the topic that we have started last week, and we have covered a few things with Arush, and we will see what we know and what we need to know. Okay. So unit circle, when you talk about in layman's term or in my term, okay, I'm pretty much a layman. I try keeping things as simple as possible. I know this one is not looking like a circle, but you guys can see the board, right? There's a circle I'm trying to draw. Yeah?
Yep.
So when I say unit circle, I'm essentially talking about a circle with radius of 1 unit. Yeah? And this is used extensively on the top of our SOHCAHTOA understanding. Meaning, the trig functions that we know about, right? SOHCAHTOA tells us that there are ratios, sine, cosine and tangent. So sine is nothing but opposite side. So if let me try drawing it. If I pick a point P on the unit circle, that is making an angle theta with the positive x-axis. Then let's visualize this as like a right angle triangle first, then we'll come back to unit circle. So let's say this coordinates will be x comma y. X coordinate is this length and y coordinates value is this one. So SOHCAHTOA says, and this is a unit circle, so I'm saying this is a radius of 1. SOHCAHTOA says that let's call it radius for now. I'll not say what. So Sokatua says sine of an angle theta is the opposite side by hypotenuse. So here opposite side is y over hypotenuse, which is r. Cos of a theta, this part, cos of a theta is adjacent side by hypotenuse. So this is adjacent side, which is x over hypotenuse, which is r. And tangent of an angle theta goes by this is opposite side by adjacent side. So opposite side by adjacent side. Y over x. Yep. Since we are talking with respect to unit circle now, meaning same circle but the radius of 1 unit. So this r is nothing but 1. And hence, everywhere where you have r, you will replace that with a 1. Oops, sorry. Y over x. So sine of a theta became y over 1 or y equals sine theta. Cos of theta equals to x over 1, that is x. So x equals cos of theta. So whatever were the coordinates of this point on the perimeter of the unit circle, which had coordinates x and y, we can replace that with cos theta and sin theta respectively. Yeah. So that's the basic premise of a unit circle, which says any point on the unit circle, your coordinates will be cos of theta, comma sin of theta. Yeah. And this theta is nothing but the angle that it makes with the positive of x-axis. Yeah. So here what's happening is you have your coordinates known and you know how to find out the sin theta and cos theta.
Yes.
Let's go back one step backward, and go back to trigonometry alone. Let's park the unit circle for a little bit, just to digest or understand the concept of inverse functions. So let's say if I have a right angle triangle. If I have a right angle triangle or right triangle, whatever you call it, and I'm talking about this angle theta, this is let's say A, this is let's say B, and this is my hypotenuse, I will call it H. Okay? So going by Sokatua, it says sine of a theta equals, in this case, it will be, sine of a theta will be opposite side by hypotenuse. That will be A over H. Yeah?
Yes.
So when it comes to inverse, so here you know the sides, and from that you can find out the sine of it. Okay? Or if you know the theta, you will be able to find out the relationship between A and H, right? That's a resistor ratio. What inverse function says is sine of theta is equal to E over H. I want to read it differently. I want to look at inverse sine function. This will be equal to theta. So basically, if you know A over H, you can find out sine of theta. Or same thing, it's represented differently, where we are saying, okay, you can find out inverse of this will be equal to theta. Yeah. So that is basically what is called, that is what is the basic premise of an inverse function. Meaning sin theta is a ratio. Whatever the value that you are getting for sin theta, if you take the inverse of that, that will give you the angle that you are talking about.
Okay.
So it's a little confusing at times because we are all used to the exponents understanding when we say, okay, x equals is nothing but x to the power 1. X to the power 2 is nothing but x into x. If I have x to the power minus 1, that means 1 over x, meaning it's flipping upside down. That is not the case when we are talking about inverse functions. Arush, does it make sense? Yeah? So basically, the inverse functions are interpreted a little differently in trigonometry. it doesn't go by the understanding that we have so far with respect to exponents. It's little different in flavor. Yeah.
Yeah.
So now let's go back to what Vidansi was talking about, that a function cannot have multiple outputs for one input. Now we are going to dig a little deeper inside it. So basically, I wish I had an undo option here. So whatever I had drawn and erased, I could retain it back, but I will probably go back to it one more time. This is A, B, and this is my hypotenuse, this is my angle theta. So sine of theta equals A over H, cos of theta will be equal to B over H, adjacent side by hypotenuse, and tan of theta will be equal to opposite side by adjacent side, A over B. This part is okay. Now, when you relate that to the inverse function concepts, sine inverse of A over H, or it's also called arc sine, will be equal to theta. Cos inverse or arc cosine of B over H will give you theta, and arc tangent or tan inverse will give you a theta. So basically, when you find out the inverse or arc sine, arc cosine, arc tangent, it gives you, it helps you find out the angle theta in radian. So we don't use degree much in this case. We relate that with the tangent, with the radian way of measuring angles. Yeah.
Yep.
Now, so this is the basic concept of inverse function, but this is not all about it. Let's dig a little deeper into it. Are we all okay? Arush, Vidansi, both of you okay?
Yep.
And Vidansi, there is a big problem in my class. I have a very bad habit of cracking dad jokes. Bear with
That's
me.
it.
Okay? Arush has been dealing with it for some time. You are a new victim of that. Okay? Alright, let's move on. Now, let's go back to unit circle, because we have gone past the stage where we talk about trigonometry just with a right angle triangle. And if I want to kind of pick your brain, both of you, to even think about why we are breaking our head to find out why even to go into unit circle. Right angle triangle is enough to learn trigonometry. Why are we even bothering to go to unit circle? Any thoughts around it? Arush?
To graph the trigonometric functions.
To graph the trigonometric function. Okay, that is one possible answer. Arush, any thought? Because the whole suka to our trigonometry starts from right angle triangle. Why we are going on this far and adding or learning something new to complicate our lives?
You could maybe to see ratios better, because you could fit that triangle into the circle, and you could find a lot of, like, you could find trigonometry.
Okay. So let me give you guys a very basic thing, okay? Look at this triangle. Any triangle, the best triangle in the world, also cannot go beyond 180 degree. Okay? And since the whole trigonometry concept originated from a right angle triangle, so essentially we are talking about one angle being fixed 90 degree and other angles can be manipulated for up to a value of 90 degree. So right angle triangle gives us a restriction of measuring value of sine, cosine and tangent only up to 90 degree. You cannot go beyond that. But when you are looking at unit circle, see this, you picked up a point. We have just learned that any point on unit circle, the coordinates will be cos theta comma sine theta.
Yeah.
And sky is the limit. Meaning here, and this theta is nothing but the angle that it makes with the x-axis, this theta, positive x-axis. If you come and pick a point here, we are essentially talking about something more than 90 degree. You traveled all the way to the third quadrant. you're talking about angle more than 180 degree. You travel all the way till the fourth quadrant, you're talking about an angle more than 270 degree. Yeah? You keep going in loop, 360 degree, 720 degree, 1080 degree, whatnot. You can iterate through this loop, this circle as many times you want. And we can also even talk about, okay, let me try finding out the value of sine of 5090 degree. And you can do that with unit circle. So first thing is, the unit circle gives us the ability to go beyond the restriction that comes with right angle triangle, beyond the angle more than 90 degree. Yeah?
But like, when do we ever need to use such absurd degrees to calculate?
Think of Earth rotating the sun. Okay? All the research that is done in the space, you will see that those are some of the scenarios where you're dealing with much larger angles. Yeah? Whenever there's a calculation around spiral stuff. Okay? So imagine, I mean, again, I know Earth doesn't revolve around sun in a circular path, right? It's elliptical in nature. But that's just a reference. Think about the fan rotating, okay, the ceiling fan, okay? And let's say somebody has to find out how much energy is consumed in 30 minutes, okay? And 30 minutes, let's say it makes 2 million rotations, okay? And then every rotation is 360 degrees. You'll find out how many rotations is made. And let's say you are talking about 2 time window, okay? The starting point here and the ending point here. So from starting point to ending point, you're not always making a complete rotation, okay? You might have stopped here in the time frame. So 50 rotations and then this much. So basically, when you're talking about measuring something when you're going in loop, it's just not, or related this way. When you're talking about a right triangle, you're talking about 2-dimensional space. Our life is more around 3 dimensions, right? So all the measurements that we do, I mean, think of even car's movement, right? Your wheel is rotating. So there's a lot of thing, that gets calculated while designing the car. How many rotations? When you're applying the brake, let's imagine this. You're applying the brake and you are going at 70 miles per hour and you have only 20 feet to stop. What will be the force applied so that in 20 feet it makes 3 rotations, 3.5 rotations, let's say. Right?
Yeah.
So you will not wait for the car to make full 4 rotations and then stop. By the time you would have hit the car in front of you. I mean, again, I'm not trying to relate it that way, but what I'm trying to say here is there's a lot of calculation you're doing with multiple rotations to get to a new result. And think of the accuracy nowadays people are talking about. Tesla is a classic example. If you know that they have full self-driving mode, correct?
Yeah.
And full self-driving mode, you get the starting point and ending point and it drives you to that place. It calculates each and every inch movement accurately so that the car stops well before the stop sign, turns at the right place, right? So it's counting how many rotations I have to make and then stop if this is the distance to cover.
Okay.
Yeah? So these are some of the examples, okay? I mean, there could be much more to it. Maybe I'm not getting not giving you a lot of good examples, but you can always assume that when you're measuring things, you're not always measuring in one complete rotation, okay? There could be 1, 1.5, 2.25 rotations, and all those things will come into play, and there'll be a lot of horizontal and vertical movements that have to be calculated to arrive at what is the accurate finding around this, right?
Okay.
Even the space research thing, right? They talk about precision to the level of 8 decimal points or 10 decimal points. To get to that level of accuracy, you need different tools and techniques that gives you that ability.
Okay.
And it goes well beyond this limitation. I hope I was making a little bit sense. I know I'm probably not from the same field where I can give you more data points, but I'm just trying to relate it like a normal human being.
Okay.
Arush, does it make sense to you as well?
Yeah.
Okay. So, going beyond this, we started with what is inverse function and basic definition of inverse function. Then we did a recap of where we are with respect to, or how do we relate unit circle or any point in the unit circle, how does it relate to the angle, and why do we need to talk about unit circle. Now that question was valid, and that gives us some more clue. Now let me do a quick check before I move on. Now, if you ever talk about, let's say, sine of a theta. Sine of a theta, what is the minimum and maximum value that you can think of? Sine of sine of 0 degree is 0. Sine of 90 degree is 1. If you read that in radian, sine of 0 radian is 0. Sine of pi by 2 is 1. Is that all about it? Or we can have more values of sine theta?
We can go more, like to. Oh wait, it's been so long with the radians. I forgot the value, but we can go all the way back to 0.
So you're saying that you can move from here all the way back to 0. That's what you're saying?
Yeah. Yeah. Then the value relapses again.
Okay. Now let's look at it. What is sine of theta? Let's say this is my angle theta. Okay. When theta is 0, this is my y value, which is nothing but sine theta in a unit circle scenario, correct? And when it's 0, my y value is almost 0. When it's increasing, it goes to a higher value, and it goes till the theta is 90 degree. This is my maximum of y. Okay, this becomes 1 for pi over 2. And then when I increase my angle, see my y value further decreases.
Yes.
And when it comes to pi or 180 degree, it becomes 0 again. Then when I go further in the third quadrant, when I change the degree to 190 degree, 200 degree, 240, 250, till 270, it again became 1.
Yeah.
But remember, it did not become 1, it actually became minus 1. This is a y quadrant, right? This is unit circle, this is 1, this is minus 1, correct? And then again, if I go to fourth quadrant, if I keep increasing the degree, from minus 1, it keeps increasing because it's increasing as it's decreasing its negative value. Minus 1 becomes minus root 3 over 2, minus 1 by root 2, minus 1 by 2, and then 0. So it increases from minus 1, goes all the way to 0. Yeah. And then now, see, this is what is happening now. If you are again going from 360 to 400 degree, your y value is again increasing, and further decreases.
Yeah.
Making sense? Arush, are you with me?
Yeah.
So what I'm trying to convey or derive from this is that my no matter how many times I'm revolving around this circle, rotating around this perimeter, along this perimeter, my y value or the sin theta value starts from 0, goes to 1, decreases, goes to -1, comes to 0, again increases. So basically my sin theta value hovers between -1, 0 and 1. Make sense?
Yeah.
And that is what you would have seen while plotting the sine curve. You would have seen that when you plot a sine curve on a coordinate plane, it oscillates between 0 and -1.
Yeah.
Correct? That is what. So here when I look at sine theta equal to, let's say in this case, y, let's say in a right angle, this is, let's say, A, B, and this is hypotenuse. Sine of theta is equal to A over h. So, and if I am converting this to inverse function, so theta will be equal to sine inverse or arc sine of A over h. And in this inverse function, what you are seeing is theta has no limit, but this value, this thing is giving you. No, let me not put it that way. Let me. So if I'm trying to find out, let's say sine inverse of A over B equal to theta. This is my inverse function, right? Sine theta equal to A over h. Let's say A over h. So sine inverse of A over h is giving me theta. What we know is this, when we are trying to find out the value of sine theta, value of the angle, this is my inverse function. And what you mentioned, I keep forgetting your Vedansi. It takes me a couple of classes, okay? If I forget your name, just matter of few weeks. So Vedansi, as you mentioned that, so this is an inverse function. This will give me a value of theta, okay?
Yeah.
Now, my angle, see, my sine value fluctuates between my value of this thing, which is going as the input to this function, A over h, is fluctuating between what? -1 and 1. That's the maximum range it can talk about. Yeah?
Can you repeat that part?
So I'm saying, let me put the sine value and the inverse function together. So this is my triangle, this is my side A, this is my angle theta, this is hypotenuse, this is B. I'm just, before I get you guys confused with the unit circle, I'm just looking at the basic sine of theta is A over h relating to this triangle, okay? And sine inverse of A over h will be equal to theta. Yeah?
Yeah.
So, when we are looking at this function, we are saying that this is inverse function or arc sine. So, every function has two things, input and output, right?
Yeah.
Domain and a range, right? So, here A by h is going as your input to this inverse function, correct? And you are getting the domain.
Yeah.
Here in this case, what will happen is A over h, this A over h, the ratio A over h, the value of sine theta, this can only fluctuate between -1 and 1. It cannot go beyond that. Correct? So, another thing is, if you just look at, let's take one scenario. Let's say, do you guys remember what is the value of sine 30 degree?
Sine 30 degree. If I'm correct, it is the y value is root 2 over 2. Oh god, it's been like a summer since I did this.
1 by 2. Sine 30 is 1 by 2.
Yeah.
Yeah? Arush, do you remember that?
Kind of a little bit.
Okay. So we will come back to that also. So sine of, let's say sine 30 degree. Okay.
Okay.
Sine 30 is 1 by 2. So sine inverse of 1 by 2 is 30 degree. Okay. I mean, if I go by the definition of inverse function. Now what you are seeing is, in this unit circle, when this is 30 degree, you get 1 by 2. When you make a complete rotation, then come back to this point again. By meaning 360, 2 pi plus 30 will also land you in the same place. 4 pi plus 30 will also land you in the same place. 6 pi plus 30 will also land you in the same place.
Yeah.
So what's happening is, for multiple inputs, so you are getting same a by x value, 1 by 2, you are getting multiple range. For the same one domain, you are getting multiple range.
Yeah.
And that is not a function.
Yeah.
So that is where, that's the word of caution, okay? It has nothing to do with what we have learned so far. Since unit circle tells us that every complete rotation plus that angle gives us the same value and lands in the same place, my absolute value for that angle would be the same, but it says that when you are dealing with the inverse function, be careful with respect to how you want to limit it, how you want to constrain that function so that your domain and range doesn't give you conflicting answer. Otherwise, it defies the whole purpose of what we use a function for. Okay?
Yeah.
So now when we look at some problems, right, relating to this, we'll be able to clear a bit of dust. Okay? So let's do a quick recap of what we have learned. We just did a recap of what is a unit circle. We looked at what is the possible, any point in a unit circle, what will be the coordinates of that. Then we looked at what is the basic definition of an inverse function and how it is different from the understanding that we had built with exponents. And then we are saying that Vedansi told us that when you have a function, you have to have one output for every input.
Yeah.
When one input gives you multiple outputs, that is when you are leading to confusion and you are defying the basic concept of a function. Yeah? So that's why we said that, okay, fine. When we are looking at the inverse function, we have to be very clear because every one rotation gets you in the same place, and hence for a given value of the sine theta for which you are trying to do inverse and find out the angle, for given value, if you are just going by the basic definition of inverse functions, you will get multiple angles, theta, 2 pi plus theta, 4 pi plus theta, 6 pi plus theta, so on and so forth. Yeah? So that's where you have to restrict, you have to define your boundaries when you are talking about inverse function, because one value of sine theta would give you multiple angles actually if you are trying to derive that using inverse functions. Yeah?
So we would have to restrict the function till 360, right?
Not always. Now look at sine theta alone. See, your sine value is fluctuating between 1 and minus 1. Yeah? Correct? Sine theta value for any angle of theta is fluctuating between 1 and minus 1, right? So, when you increase theta to 90 degree, you are hitting 1. When you decrease theta to minus 90 degree, you are hitting minus 1. Why do you have to even go to third and fourth quadrant? Because your sine theta value is the vertical dimension, right? Which is oscillating this way. So when you are talking, okay, so now you are kind of making me give you a pinpointed response to this. So what is my sine theta? Sine theta is my y coordinate, meaning this vertical length, correct? Yeah? Is that okay with that?
Yeah.
Yeah. So if I'm talking about sine of theta, sine inverse of let's say A over B, then here when it comes to the angle, I am good with up to 90 degree to get a maximum of 1, and I am good with minus 90 degree because when we are going clockwise, we are measuring the angle in negative value, right? So when I am talking, so what you can do is you can say, okay, my range is restricted between pi over 2 and minus pi over 2. Oh, sorry. Yeah? So you are restricting your range here.
Okay.
Yeah? So similarly, if you are looking at the cos theta, arc cos or inverse of cos function, see your cos theta is nothing but your horizontal axis, okay, the length along the x-axis. So it is fluctuating between these two. So you don't have to go to negative of theta. You will get a maximum of cos theta when cos theta is equal to 0, that is 1, and a minimum of cos theta when this becomes minus 1, which is cos pi. Yeah?
Yeah.
So for your arc cos or cos inverse function, you are restricting your angle to be between theta is less than equal to pi and greater than equal to 0. You don't have to go to third and fourth quadrant to create more confusion for yourself.
Okay.
And you're saying that, okay, I'm done with all the ranges that I'm talking about, and if I'm going in loop, I'm unnecessarily adding more options, more solutions, and that defies my basic understanding of functions.
Okay.
Yeah? Arush, with me?
Yeah.
Yeah? Now, again, these are some of the angles that we'll deal with, okay? So the most commonly used angles are 0 degree, 30 degree, 45 degree, 60 degree, 90 degree, okay? And in radian, if you look at it, obviously it's 0 radian, pi by 6 radian, because pi radian is equal to 180, right? So when I say 30 degree, I'm talking about pi by 6 radian. If I'm talking about this, I'm talking about pi by 4 radian. If I'm talking about 60 degree, I'm talking about pi by 3 radian. If I'm talking about 90 degree, I'm talking about pi over 2 radian. Okay?
Yeah.
So these are the most commonly used angles. And there is a table that I'm going to draw on the table, on the board. And that table, I'm not asking you guys to memorize because I hate when it comes to memorizing things. Okay, I'm very poor when it comes to memorizing things. Okay, but somehow with age, with practice, with enough of hands getting dirty, I have kind of memorized the tables. But I'll also show you guys how do you derive it on the fly. Okay, you don't have to memorize everything. Let me put a table here real quick, and we'll try to wrap up the class in another 10 minutes. Okay, so this is the table. Sine, cos, tan, 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. Sine 0 is 0, 30 is 1 by 2, 45 is 1 over root 2, 60 is root 3 by 2, and sine 90 is 1. Cos is just reverse of it. Okay? So whatever you have for 90, that is the value you have for 0. Whatever you have for 60, that is for 30. And whatever you have for 45, that is this. Same. 60, whatever you have for 30 degree, that is the value for 1 by 2, and this is 0. So 0, 1 by 2, 1 by root 2, root 3 by 2, 1, that just got the order of reverse, same thing. Okay, and then 10, you know, it's sine over cos. So 1 over 0 over 1 is 0. This is 1 over root 3. This is 1. This is root 3, and this is undefined. Okay. Now you will say, why we have to memorize this? We don't have to memorize this. Okay. You will end up memorizing it without putting any effort for it. Now look at this. Sine of 0 degree. Okay. Let's look at it quickly. This is theta. This is, let's say, A. This is B, and this is hypotenuse. Okay. Sine of 0 degree. When you are saying 0 degree, when this angle is 0, what is happening here? Hypotenuse is actually falling on this line, and this height becomes 0. Correct? This height A becomes 0. Correct? Sine of theta is this height divided, the opposite side divided by hypotenuse. When you make this angle 0, what you are doing? Actually, you are making this line fall on this line, horizontal line, and your height becomes 0. Yeah? 0, I mean, when this angle is 0, right? When there are two lines and the angle between them is 0, what you are doing? Two lines are there, sides, the angle is 0, you are actually making the line fall on the other one, correct? Yeah. And the height, the gap between the two ends becomes 0.
Yep.
So 0 over hypotenuse. It doesn't matter whether you are saying hypotenuse is 1 million units, doesn't matter. 0 over anything is 0 only, correct? So that's how your sine 0 is 0. Okay? And there is a concept of complementary angles, right? Sine of theta is equal to cos of 90 degree minus theta. Correct? So this is theta, this will be 90 degree minus theta, correct? So if I am taking this angle, so what I am saying is sine of theta here is what? A over h. I am saying sine of theta is equal to cos of 90 minus theta. So we are looking at the concept of complementary angles, okay? When you say complementary angle, meaning one angle is theta, second angle is 90 degree minus theta. So that when you add them together, it becomes 90 degree, correct? So I am saying sine of theta is equal to cos of 90 degree minus theta. Let's validate it. Earlier we were looking at this angle, now this angle is 90 degree minus theta because this is 90 degree. So that is how these three added together will make 180. Yeah? So I am looking at this angle now. Let's go by the SOHCAHTOA definition. It says cos of this angle. Now this is the opposite side and this is the adjacent side, correct? When I am looking at this angle. So cos of this angle will be adjacent side by hypotenuse. Aren't these the same? Arush?
Yeah.
Yeah? So basically, see, these are the concepts. People will say, okay, the complementary angle concept. I am saying these are related, okay? I mean, it just goes by the basic definition of SOHCAHTOA. So, how is that useful? Sine of 0 degree, what I am trying to say is, sine of 0 degree is equal to cos of 90 degree minus 0. That is why you see sine of 0 degree, 90 minus 0 is nothing but 90. So, sine of 0 degree you see is matching with cos of 90 degree. Yeah? Are you guys getting a little loaded right now? Too many things one after another. Okay, I'll just show you guys. Okay, let's not practice the problems for inverse function today. That will be an overkill. But let's look at. I was saying that sine 30 is 30 degree, sine 30 degree is 1 by 2, and you guys were thinking how and why we forgot or whatever. Let's look at how is sine 30 1 by 2. I have an equilateral triangle. This side, and this side are the same. When you have equilateral triangle, all angles are 60 degrees, correct?
Yep.
Let's drop a perpendicular from here to the opposite side. So this was A, B, C. When I draw the perpendicular from here to here, it is meeting at a point D.
Okay.
And this angle is obviously 90 degree. This angle is also 90 degree. What did we do? We split this large equilateral triangle into two right angle triangles. Triangles ABD and triangle ACD. Meaning the one that you see in green and the one that you see in red. Yeah? So ACD is the red one and ABD is the green one. Is that okay so far?
Yeah.
Now, I'm saying that these two triangles that you see, the red and green, they are congruent. Is that something that we can believe?
Yeah.
Congruent using the theorem of congruence called RHS. For two right angle triangles, now we have these two triangles are right angle triangles, right? For two right angle triangles to be congruent, if their hypotenuse is matching and one of the side is matching. Yeah? Your hypotenuse is matching because they are part of the same equilateral triangle.
Yeah.
And this side is anyways common. So they are congruent, meaning this length here and this length here are same, is equal to half of the original length. Yeah?
Yeah.
And this angle is also same, which will make it 30 degree each. Yeah? Now let's find out what is the value of sine 30 degree. Let's take a snapshot of this triangle ACD. Okay, this is length L and this became half of the length and this is 30 degree. Okay, I've just cut this piece out and put it here. Now this is 30 degree and this is 60 degree. Okay, what is the value of sine 30 degree? Sine of 30 degree in this triangle. Sine theta is opposite side by hypotenuse. L by 2 divided by hypotenuse. L. L by 2, 1 by L. What did you get?
1/2.
Yep. Yeah?
Yeah.
And going by the concept of sine of theta equal to cos of 90 degree minus theta, put that theta equal to 30 degree here and here. So sine of 30 degree will be equal to cos of 90 degree minus 30 degree, cos of 60 degree. Yep.
Yeah.
I will leave you guys with one assignment. Do this, just watch the video of the class once I upload it. You will have to find out the value of sine 60 degree, okay? Find out value of sine 60 degree and cos 60 degree from this one, okay? And again, the clue is, this is a right angle triangle. Use Pythagorean theorem to find out this length. This length is not known yet. Find out this length and that should be able to give you the value of sine 60 degree and that will be same as cos 30 degree. Okay? That's one.
Just to send a picture of that.
You will have the entire video of the class. Whatever we have done so far, there will be a video of that. I'll upload it in a couple of hours. Watch the video of the class and then obviously you can subscribe the channel also. It's on YouTube. Okay? It's only my kids who are my subscribers. I am not a big star who is known to anybody apart from his students. Okay? So you can watch it and you should be able to drive it by yourself. Okay?
Okay.
And why I'm insisting on all these things is, whatever we learn with math, right? It's all about putting the concepts. I don't have to memorize these things. Every time I take a class for you guys, what I do, I just look at, okay, what are the topics I'm going to cover? Am I myself clear about these concepts? And if I'm clear, I can blabber for hours. Yeah? With that being said, I will let you guys go and hope we learned something.
Okay.
Yeah?
Yeah.
Alright, have fun.
Okay.
Bye.
Thank you.
Bye Arash. Bye Vidansi. Bye bye.